Okay, so I want to find the proportion of wins. What are the chances that the proportion we win is at least half? So I guess I'm going to use my graph, normal distribution, and view probability. And we need a mean and a standard deviation here. I haven't really talked about that, so we might have to go back to our Word document and do a few little computations here. So let's add in some computations. What are our mean and our standard deviation? Well, we know that the probability of winning is 18 over 38. So that is going to be what I would expect to happen over 30 spins. I would expect to win a proportion 18 out of 38 of them. So 18 over 38, that is my mean. And what does that come out to in decimals? Because I have to enter a decimal into Minitab. So that's 0.4737. We'll use 0.4737. And what about our standard deviation? Well, we haven't actually talked about how to do the standard deviation on a proportion, really, but there is a formula. So you can find it from the formulas we found before. So this p minus times 1 minus p was part of the standard deviation of the binomial distribution. And the square root's here because the binomial distribution formula was for variance, and I've taken the square root to turn into a standard deviation. So the p times 1 minus p was there for the binomial distribution, but the binomial distribution was finding the number of successes, not the proportion of successes. So like if we win 14 out of 30, the binomial distribution would be looking for the 14, not for the fraction, 14 divided by 30. So the variance for the binomial distribution would be p times 1 minus p times n. When you turn it into a proportion, it's a little bit complicated because this is kind of like an average that we're approximating by the normal distribution, but you end up with an n in the denominator instead when you do the proportion and find the variance of the proportion instead of the variance of just the count. So I'm not going to do a proof of why this ends in the denominator instead of just being gone or something like that. But this is our formula for the standard deviation for a proportion on one of these sort of success-fail Bernoulli experiments. And so for our particular example, our proportion of winning is 18 over 38. And then 1 minus that, so 38 over 38 minus 18 over 38, that gives 20 over 38. And we are going to be spinning 30 times. Okay, so I'm not going to put it on my screen, but I'm pulling out a calculator here to compute what this would be. All right, and I'm coming up with 0.0912 equals 0.0912. That's going to be my standard deviation. Okay, let's bring Minitab back up. Where's my Minitab? Here's Minitab. Okay, so we had a mean, the proportion that we expect to win is sort of our odds of winning. That's 0.4737. Hopefully we do better than that and come out ahead. Our standard deviation, 0.0912. 0.0912. Okay, so we'll do the shaded area, and these become a little bit confusing because when you're looking for proportions, they're decimals between 0 and 1. That's sort of like probabilities. But I want to find the probability that we win more than half. So I don't know the probability. I know the cutoff point, and I want more than half. So that's a right tail for more than, and we want more than half. So I put in a 0.5. And we'll hit OK and see what we get. So my answer is 0.3865. Okay, so that's my 0.3865 is my answer. All right, so we also want to do this for 300 spins. So the mean's going to be the same, but the standard deviation has to change. So now the standard deviation is going to be following the exact same formula, except the n in the denominator is a 300 instead of a 3. So I'm getting 0.0288 for my standard deviation now. Okay, I want to double check that just to make sure. So I'm not 100% confident I didn't make any typing errors in my little calculator here. Okay, so we're dividing by 300, take the square root. Okay, so I got the same thing both times, so hopefully that's right. That's the only thing that changes, is standard deviation. We have the same mean, we still expect to win 47% on average. Sometime we're going to win more than that, hopefully win a lot more, and we do more than half. So we still want to find the probability greater than half. So that's 0.1806, 0.1806. Okay, and then let's repeat that one last time for 100,000 spins. So same thing, we just have to recompute our standard deviation a third time, but we divide by 100,000 in the formula, take our square root, and this time I'm coming up with a standard deviation of 0.00158. 0.00158. Okay, so there's an extra 0 in the standard deviation. Cranking up the denominator to 100,000 made a big difference to that standard deviation. So what are the chances that everyone playing in the casino as a group comes out ahead? Basically, what are the chances that the house loses money on roulette that day? It just says 0. Okay, so I mean, this is way, way, way down the tail. Like you can see how the bell is way over here, and this is far, far, far down the tail. So it isn't actually 0, it's just 0 to many, many decimal places, more decimal places than Minitab cares to show. In older versions of Minitab, I was actually able to sort of click on this 0 and get more decimal places, but it's not letting me do it here. So the chances that an individual could come out ahead playing a number of spins of roulette is solid. Like we were saying, like 40%, 38%, 18%, but the casino is not going to lose. The chances of them losing are way, way, way down the line. So even though there is randomness in the gambling game, the casino is not going to be losing money. Okay. So I'm going to end this video here, and then we're going to have a follow-up question to continue this example in the next video.